All right, welcome back, ladies and gentlemen, to the second video of the day. So as promised, we're now going to take the same data that we just ran a hypothesis test on, and we're going to build a confidence interval, a 95% confidence interval. And the goal is to try to use this interval to capture the true value of mu1 minus mu2. Now, in the previous video, we just ran through a hypothesis test where we failed to reject the null hypothesis. In other words, at an alpha level of 0.05, we fail to reject the fact that mu1 minus mu2 is equal to 0. So it's feasible that there is no significant difference between these two populations with respect to that parameter of GPA in AP Stat. All right, so that being the case, we should expect that our confidence interval contains 0 at a 95% confidence level. So real quick, the plan, justify, show, summarize stage would be required if you're doing just, your own confidence interval problem. But since we already went through those stages for the hypothesis test, I'm just going to highlight what would be different between those stages. So what you're looking at here would be a proper plan stage, at least this portion over here. Change the pen to red. This portion over here would be a proper plan stage for a confidence interval. And you might want to just be clear that we're using a 95% confidence level. Right? So we've named the procedure, we've defined the parameters of interest. We have our confidence level. Notice that there are no hypotheses. That's because whenever we build a confidence interval, we're not making any assumptions. Okay, we're just simply taking the statistics and running through the process in order to try to gauge the parameter. The parameter in this case really is mu1 minus mu2. All right. As far as the conditions go, I'm skipping that step because the conditions for a two-sample t-interval are exactly the same as the conditions for a two-sample t-test. So I'll scroll up to what we did earlier to show you what those conditions are. So we have the random selection, which you saw in my previous video, mentioned the 10% condition, the nearly normal condition, and independent groups. These conditions are identical. None of these conditions actually depend on the null hypothesis, and therefore the conditions here and the conditions for the confidence interval are exactly the same. All right, so the justify stage is done, and let's move on to sort of the show stage, and that's what you're seeing now over here. I haven't shown all of it yet, but this is part of it. So as long as the conditions are met, then the difference in sample means should be distributed using the t distribution, centered at mu1 minus mu2, which in this case we aren't sure of, and we're trying to gauge what that value is. And our standard error is actually exactly the same as the standard error for the hypothesis test, because we used the sample standard deviation for each sample to approximate the standard error of this sampling distribution. Now remember that when we construct a confidence interval, whatever our confidence level is, that will be the amount of data that's in the center of the distribution, which in this case means that our tails, that should be 5, that our tails have about 2.5% of the overall data. This should look familiar actually. So when we were discussing the distribution and the rejection region of our two-tailed test at a 5% alpha level, notice that the rejection region was 2.5% of the overall data in each tail. So a lot of you read and asked this question about the relationship between a confidence interval and a two-tail hypothesis test. And basically it comes down to if your alpha value plus your confidence level is equal to 1, then the two-tail hypothesis test should agree with your confidence interval, right? So what do I mean by alpha value and confidence level equal to 1? Well, in this situation, you can see that our alpha value was 0.05. Our confidence level of 95% or 0.95, that refers to the center of the data. So when we sum those two values together, we get the entire distribution. And that entire distribution is using each tail as part of the rejection region. So it turns out that if we observe a sample that's not in the rejection region, which is actually what we saw in the previous video, then we end up observing, actually, I think our observed stat, actually, I think our observed stat was more to the left over here. But the point is that when we build a confidence interval around that observed statistic, it should include 0. I know this is getting really messy, so let me scroll down and show that again over here. It turns out that our observed statistic is somewhere around here. As we saw from the previous video, that number was not in the rejection region. How do I know? Well, I did not reject the null hypothesis. And so it should turn out that when we build a confidence interval around our observed stat of negative 3.125, it should contain what we hypothesized to be the true difference in the parameter. So it should contain 0 is what I'm trying to say. Well, let's see that it does. A confidence interval, remember, is always centered around your observed statistic, and then we add and subtract the margin of error from that number or to that number. And the standard error is still 2.7339. The only thing we need to calculate is T star. So let's go ahead and do that. So I'm going to show you how to, by hand, calculate T star, or, well, not by hand, but the long way, how to calculate T star. You're going to press stat. Again, wrong. You're going to press second vars, which will give you the distribution options. And we're going to scroll down to inverse T. Again, some of you might not have this, in which case you'll need to use the T distribution table. And as far as your degrees of freedom go, just round to the nearest integer and use the degrees of freedom that is closest to what the table has. All right, so inverse T, area. So we're talking about area to the left of this upper bound, right? Over here, area to the left of this value. That, of course, is the 97.5th percentile. So I'm going to type in 0.975. The degrees of freedom, that's the same number that we found earlier. And it was 4.3035. Enter, enter, enter. And this will give me my T star. So you can see it's 2.7009. Let me write that in. Okay, and our 95% confidence interval then will be negative 3.125 minus that product and negative 3.125 plus that product. I'm going to sort of skip going through the hand calculations and just run the test to get the numbers. So if you press stat and scroll over to tests, you can scroll down to two sample T interval. Again, I have the data in list 1 and list 2 still, so I'm going to use that option, data. My confidence level is 0.95. I'm not going to pool for the reasons explained in the earlier video, and hit enter. And this will give me the lower and upper bounds as well as the degree of freedom. So it gives you all that information again. So my lower bound is negative 10.51. This is points, right? Difference in points. And 4.2589 points. All right, so let's summarize. What does this confidence interval tell us? Well, basically it says that we are 95% confident that the true difference in mean GPA and mean stat GPA between sophomores and seniors, mu1 minus mu2, is between negative 10.51 points and 4.2589 points. Okay, that just summarizes or interprets the interval itself. So basically, I want to point out that the value 0 is in this interval, which means it's feasible that there is actually no significant difference. And that should not be a surprise that 0 is in this interval, because that agrees with the hypothesis test that we just ran. Right? Remember the hypothesis test, we failed to reject the null hypothesis. The null hypothesis was that mu1 minus mu2 equals 0. And we failed to reject that fact. So it's feasible that there is no difference. And we're seeing that both from the hypothesis test point of view and from the confidence interval point of view. Oop, that was going to be something else. But anyway, so that's all for today. I think I'm going to do next week a separate video on the relationships between two-tailed tests and confidence interval, just to give you some more general information on that concept. But hopefully this illustrates what you saw today, illustrates why there is that relationship between two-tailed tests, two-tailed hypothesis tests, and confidence intervals, as long as alpha and confidence level sum to 1. All right, folks, I hope you have a nice weekend, and I hope you enjoyed these videos. Take care. Bye.